Team Hexeco, the last representative of CTU, will impress us with modern housing, where good look hides even nicer soul.
Thank you. So good morning, my name is Josef and this is Jirka, and let's get into it. Our challenge was to develop or implement regenerative technology in residential housing. You may ask what regenerative technology is. It's basically taking a step further from sustainable technology. Sustainable is making no harm, but regenerative technology is basically helping nature to restore itself after the harm we did as a humanity. We try to solve these 4 problems with our solution, and those are high building energy demands, polluted air, drought, and overheating of urban areas, which all are very recent nowadays. So yeah, this is our concept. It's a hexagonal cell, it's a flat unit, and we went with this shape because we try to minimize area for heat transfer, so it's energy efficient, and it's modern, and it's compact, and we got a little bit inspired by a beehive, so by nature itself. And if you stack it together into a block of legs, it looks like this. Each cell will be made out of a thick concrete wall, because concrete can accumulate coolness pretty good, so it can retain coolness of the night and give it out during the day, so you save some energy for cooling. Algae facade, there is a special kind of algae which helps with air cleaning and serves as an insulation. Rainwater recycling tanks does the drought problem. Another air cleaning device which is all natural. And now we are approaching a zone of our inventions. It's an Icarus system for better work with the sun energy. And another air conditioning device, and another air conditioning device. And now I would like to give floor to Rika to tell you more about it.
Okay, so how to achieve regenerative attributes? We have to be more effective. The idea is to capture every beam of sunlight and use it. Therefore, the system of semi-transparent mirrors was designed. Each ring has several lamels, and these lamels can be tilted, and each ring can rotate. Thanks to that, we are able to rectify the sun beams and send it to some solar panel or a heat collector. Also, passive cooling system based on radiation phenomenon was designed. There is heat exchangers as collectors on the north side of the building, and they are tilted to night sky. The water flows inside these collectors, and it radiates the heat towards the sky, and it works because the sky has a low temperature. So we can cool down the water that flows inside the building, inside the concrete walls, and it helps to stabilize the temperature during the day, and it's passive. Also, we try to merge root zone treatment and cooling system. Especially, our idea is to use high thermal capacity of water reservoir, so we can use air-to-air heat exchanger system and upgrade it with adiabatic cooling, so it is more effective. So what we have solved? We come up with idea how to gain more energy from sun. We solved the pollution, water and air, and also come up with 2 ideas how to do passive cooling. Okay, so thank you.
Very nice timing. Good job. We have questions from the jury, and I would like to start with Mr. Miller if he has a question, because he is online and he didn't have a chance so far. So maybe he can be the second.
Dankeschön. Thanks, guys. Lots of really interesting ideas and visions in this. I have two questions, as always. First, do you have done any calculations? Do you have any numbers in terms of like the lifetime or life cycle effect of this product in terms of CO2 or other gases, the climate in general? Do you have these kinds of numbers or calculations? I would be curious to see that. Secondly, I was curious that you have chosen to use thick concrete walls for this, because I do get what you said about, you know, storing heat and releasing heat, but to my knowledge, it's quite CO2 heavy to produce concrete. So, and that's also why I asked the first questions: how does this add up in the total sort of calculation of in terms of the climate effect?
Well, I'm going to answer to the thin concrete walls at first. This design was made to be very robust, to hold for a long period of time. So, yeah, firstly, it takes kind of a lot of CO2 emissions to create it, but at the same time, I think it will pay off in a longer period of time.
Yeah, and about the first question, we were challenged by that company, and the company wants for us to come up with some new solutions, new designs. We don't have specific numbers. We come up with some ideas that should theoretically work, but we have no resources to try it yet. Yes.
Okay, I get it. Thank you.
If I may add another question, you collect rainwater, as I have seen. How much rainwater would you then have? I mean, the budget. You cool the building, or is that type of building specifically useful in some areas of this country, or have you made a budget, a water budget?
I think that our challenge was to design this as more for Prague. So yeah, we think that here in Prague, we think that there should be enough water. It is getting worse because of global warming, but we're calculating that it should be enough.
Well, there was an idea in the beginning that we could actually use this Ronzu treatment to even clear the water in rivers, so we could theoretically, in some areas where some river or streams are nearby, connect it to it. And about the rainwater, it would be used also for cooling and I guess just for some gardening.
Thank you so much for introducing thoroughly this new technology. But I would like to know from you, what happens next in your project? What are the next steps you need to take, and what kind of support do you need on that?
Well, we are in contact with GRD company, and now it's kind of blurry what's going to happen next. I don't think that our project and its whole beauty is going to come to reality anytime soon, but the people from GRD, mostly engineers, were interested in a singular technical solutions. So we will see what's going to happen next.
Yeah, you can have a question because Professor Miller is not online anymore.
All right. For the next steps, we have in Eindhoven, we have 2 student teams working on circular and environmentally friendly buildings. So I would say reach out to them because I think it's a really interesting concept. If you are going to make safe and healthy environments, yesterday you had a workshop on inclusion. Can you think of a target group that you would, like, can be anywhere in the world, that you think this concept would be uniquely suitable for?
We were thinking mostly about young families because this idea behind this was to make it cheap to buy and cheap to live in, because of most of the technologies are passive or do not require much energy. So yeah, that's our target group.
Okay, thank you.
All right. Thank you very much, guys. Do you have another team member here?
No, that's
No, it's just the two of you. Team Hexeco. Thank you.
Thank you.